Okay, so we're now going to move on to polynomial regression. Earlier this semester, we entered data into our calculators or into GeoGebra, and we performed linear regression. This is your second project. So now we're going to see what to do if the data is not very linear, right? If a line is not a good fit. Because remember, for the project, you had to reject certain data sets if the correlation coefficient wasn't, I think it was 0.6 or above, or below negative 0.6. So if a line's not a good fit, we can use something else to create a model that matches the data. So here we have a table that shows the number of women in the full-time civilian labor force. This is measured in millions, with children under the age of 6. Okay? Number of women with children under the age of 6 in the full-time labor force in various years. So I want to look at a scatter plot of this data. I can do that in my calculator, or I can do it in GeoGebra. We know how to do that in both of those places. I'm going to do it on my calculator today because if anyone, for the activity, I'm going to have you use calculators, and I'll give everyone one if you don't have one. Okay, so I'm going to enter this data into my calculator into list 1 and list 2. Again, we've done this before. Okay, so to enter the data, I think we're going to let T be the number of years since 1970. So instead of 1975, I'm actually going to enter what? 5. And then 10, 15, 20, 25, 30. Okay, so to get to the place where you enter the data, remember you press the Stat button. Then you go to option 1, which is Edit. And you've got a list 1 and a list 2. This is where we put the data. What? Do you need me to start over? So press the Stat button. It's right underneath Delete. Press the Stat button. Choose option 1, which is Edit. And there's your lists. Okay. If there's data in there, you can highlight the name of the list and press Clear. Remember, we don't want to press Delete, just Clear. All right, so now I entered the data, all the X data or the year data in list 1. So 5, 10, 15, 20, 25, 30. All right, and then I'm going to put the Y data in list 2. 4.851, 5.886, and 9.736. We're going to find the line of best fit and the parabola of best fit. Okay, so we're going to fit a line and like a U, a parabola. If you miss any of the commands that I'm about to go through, there's a step-by-step instruction sheet a few pages later. So when you're doing the activity, you can always refer to it. Don't feel like you have to frantically write down what I'm doing. It's all written down. Okay, so to find the equation of the regression line and the regression parabola, first thing I'd like to do is look at a scatter plot of the data. So I just quit out of here, second quit, and I'm back in my home screen. And I go to y equals. If there's anything in there, I should get rid of it because it's from an old problem. And then where it says plot 1 up in the left corner there, I want put my cursor on there and press enter so that now it's highlighted. Okay, good. All right, and then we can look at the graph. You can either choose a window by going to window and picking what X and Y values you want to look at, or you can press zoom 9 and it will automatically give you a perfect window for your data. So if you press the zoom button and then number 9, it zooms stat. And it will automatically plot all your data. That is not what it should look like. I must have a typo, right?
No, don't say that.
Because 4.851, there should be a jump. 4.851 should go up to 5.886. Yeah, so this dot up here looks weird. Let's look at my data. Edit 4.851. No, that's right. The fourth one down. Ah, there we go. 20. Okay, that should do it. That's better. Back where? To your data? Stat. Yep, the stat button's right under delete. And then choose number 1, edit. Yep. And once you fix that, you can just press graph and it will take you right back. And you can press zoom 9 if you want to redo the window. Okay. All right, so a line wouldn't be bad, right? A regression line wouldn't be bad there, but there's a definite trend that we are not going to be able to capture with a line of that kind of like turning around or leveling off at the end here. So we'll do both models and see what we get. So I'm going to quit from the graph, go back to my home screen. We've done the regression line, although some of you probably or may not have done it on a calculator before. So we'll go through the steps. To get the regression line, you press stat again. But instead of being in the edit menu, there's 3 menus across the top. You want to choose the calculate menu. And scroll down to option 4, linreg, for linear regression. Now, if you have an older calculator like the one that's being displayed here, you have to type a few things in. If you have a newer calculator, it's prompting you for some things. And I have some pictures of that. Let me just pull those up. All right, these aren't the best quality pictures, but it's prompting you X list and Y list. It already has L1 and L2 as the default. If you had your data in a different list, you could change that, right? Ignore frequency list, right? But then store regression equation. You want to store it in Y1, right? You want to store, that's where you want it to pop up so that you can graph it. So to get Y1, you press vars, yvars, function Y1. And I'll go through it. I'll go through it in a second. So ultimately, you want to have this look like X list L1, Y list L2, store regression equation in Y1. Yes. No. Yeah, I'll put them online though for sure in the annotated notes. Yeah. Calculator. Okay. So all right, so in the older calculator, I have to know that it needs to know L1, L2, Y1. The newer calculator, it's prompting you for that information. Okay, so in my calculator, I have to say L1, comma, L2, comma. So that's saying the X list and the Y list, right? And now I have to tell it where to put the equation once it calculates the regression equation, where it's going to put it. So that's the store the regression equation prompt. And it's going to put it in Y1. So to get there, you press the vars key. So you press vars, it's right next to clear. Yeah, you need to have your cursor down in the store regression equation area. Yep. So the vars, it stands for variables, right? Because y is a variable, right? So variables. Then we want y variables. So cursor to the right to choose the y variables menu. Then choose option 1, function, and you get a list of all the different y's. So I'm just going to choose y1. And how you get this vars, y vars function y1, this is in the step-by-step thing at the end. So we press enter, and we get a regression equation. And when you press y equals, it should be stored in your y1. And then we can look at the line plotted over our scatter plot. Not a bad fit, right? It's pretty good. Press graph. Yeah. All right, and when we quit from here, we can see that the R value is 0.98 almost, which is a really good regression correlation coefficient. All right, so we've got the equation of the regression line written down. We're using the R squared value, and R squared are related exactly like you think. If you take the R value and you square it, you get the R squared value. With polynomial regression, you'll see that they're only going to give you an R squared value. So if you want to compare the fit of a line to a different kind of polynomial, you have to use R squared to compare. All right, so we're going to go through the exact same process we just did, but this time, instead of doing a lin reg, I'm going to do a quad reg, because I'm going to fit a parabola to this thing. So quit, go back to your home screen, clear whatever's there, and press your stat button. Go over to calculate, and instead of option 4, instead of option 4, do option 5, quad reg. And then you have to do the same thing. Put L1, L2, Y1. If you're using an older calculator, you just type them in a comma-separated list. If you're using a newer calculator, they're prompting you for those things. So I'm going to type L1, comma, L2, comma, and then to get the Y1, remember you go vars, Y vars, function, Y1. Oh, wait. I'm actually going to store it in Y2 because I already have the line in Y1 and I want to keep it there. So I'm going to go vars, Y vars, function, Y2. I'm going to put it in Y2 because I already have the line in Y1 and I don't want to get rid of it. Okay, so I've got quad reg, L1, L2, Y2. Press enter, and it gives me a quadratic equation. So this time it says, okay, your equation is of the form ax squared plus bx plus c, because that's what a quadratic looks like. And then it gives you values for a, b, and c. So my equation is going to be y equals negative 0.005 x squared plus 0.38 x plus 2.87. And like I said, we're just writing this down. We pasted it into Y2 so that we wouldn't lose any decimal places, right? This is just to jot down. And my R squared value is, 0.986. Something like 0.986. So 0.986 is better than 0.959, right? So the parabola should be a better fit to the data. So let's take a look at the graph and see if that's true. When I go to y equals, they pasted my quadratic regression into Y2. It looks overwhelming, but it's just because they kept a lot of decimal places. So if I press graph, now it's going to graph the line over my data because that's in Y1, and then the parabola over my data that I stored in Y2. And the parabola does look like a better fit. Yes?
If you were to, because of there's only 6 points of data, if you were to kind of keep the system and use the 7 polynomial, would it be a perfect R-squared value?
It would, yeah.
Even though it's not.
Yeah. Yeah. No. Okay, so let's use the linear model to predict the number of women who are working with children below the age of 6 in the year 2011. So 2011, how many years after 1975 is that? 41. Sorry, after 1970. Yeah, 41 years after 1970, not 1975. Okay, so I already have the equation in Y1. I've got my linear model in Y1, quadratic model in Y2. I'm just going to look at my table, right? So I hit second table, and I'm going to type in 41 for the year 2011. And my linear model says 12.646. million. Yep, your table is second graph. Okay, so let's think about that 12 million number in context. Let's think about that 12.646 million number in context. Remember what it represents. In the year 2011, the millions of women in the full-time labor force with children under 6. Does that seem like a reasonable number, that it's gone up to 12 million? It definitely has an increasing trend, so yeah, seems reasonable. What's your confidence level? Totally unmathematical. Pretty good. It's a good R-squared value. It makes sense that it went up. We'll say like, we'll just say good, right? I don't want to assign a number to it if we're being unscientific about it. All right, but the parabolic model, that's what in Y2, it predicts 10.33 million. How do you feel about that prediction? Better? How come? Yeah, our squared value was closer to 1. And we did see when we looked at this scatter plot that there was kind of a leveling off. Like it was always increasing, but it wasn't getting as, the gains weren't as big over each time interval. So this confidence level might be better, right? But let's use the leading coefficient test to think about the end behavior for each model. Like as we go way out in time, look way far in the future, what does the end behavior of the line predict? It just keeps going up forever, right? So the line predicts increasing forever. And the quadratic, what is the end behavior of the quadratic? This is its equation. What does the end behavior predict? It's going to go down to negative infinity. Yeah. So decreases to negative infinity. Let's hope that that is not an accurate model, right? Yeah. So that means that which of these lines would you choose as a model if we were going to look really far in the future? The line, yeah. Even though the quadratic model has a better R-squared value, you have to really think about the context of the problem when you choose a model and what you're going to use it for. All kinds of messes in recent history have been caused by people using models inappropriately, right? Including the whole like housing financial crash thing that was like very much caused by people applying models and saying that mortgages were really, really safe, even though we're applying those models to a whole new different data set of people that were being lent to. Among many other things, yes. Okay, so in your problem-solving process, there are 4 major steps. Create a scatter plot. Think about whether a line or a parabola or some other polynomial of higher degree would come close to the points, right? The more peaks and valleys your data has, the higher the degree needs to be to create the turning points. Find an equation for your model. Your calculator does that part. Verify that your equation has a graph that comes close to the points, right? Look at the graph and say, okay, yeah, that makes sense. If it doesn't, oops, I keep doing that. Okay. If it doesn't, you could either check your data, you might have made a typo, or reconsider your choice of model. You might say, oh, maybe a line was a bad choice. And then use your equation to draw conclusions and make estimates and or predictions, right? Like we just did up here, we made predictions based on our model. Consider the end behavior and whether or not that model can be extrapolated to data outside the data set. Extrapolation-based predictions are generally untrustworthy when you use a model to go too far outside your data set. subject to a higher risk of producing meaningless results. So, selecting a model. You have to decide whether you're going to use linear, quadratic, cubic, quartic, or none of these. Here are some suggestions. It should fit the points well. Use the simplest model that captures the pattern of the data. So there's often more than one choice that's a good model, right? The simpler model would typically be the better choice. Okay? And the model should make sense within the context of the problem, right? All right, so I'm going to let you try a few. You've got some interesting data sets and questions to answer about them.